This is the Edexcel practice test set 6, non-calculated paper, paper 1H. First question in this is a constructions question. Use ruler and compasses to construct the bisector of angle ABC. You must show all of your construction lines, meaning I have to leave the arcs in for that. I can't do this one very well on this software, but the principle is you'd put your compass point at B and draw an arc, the same arc that goes through each of the lines, then move your compass point to each of the crossing points and draw again an arc in there and an arc in there, and where those two arcs cross you then draw a straight line from B through the center of the meeting point of those two arcs, and that's an angle bisector of the angle ABC. Question 2. Peter, Tarish and Ben share £54. Tarish gets 3 times as much money as Peter. Ben gets twice as much money as Tarish. How much money does Ben get? Well, I'm going to list each of them. Tarish, Peter and Ben. Because Peter gets the least, I'm going to call Peter's amount X, Tarish's amount 3X, because it's 3 times as much as Peter's, and Ben gets twice as much as Tarish, so Ben gets 6X. And altogether they get £54, so that's X plus 6X plus 3X equals £54. That is 10X equals 54. Divide both sides by 10, X equals 5.4. And Ben gets 6 lots of that, so Ben gets 6 times 5.4. Or if I'm going to do that column method multiplication, 4 6 is 24, 5 6 is 30. So Ben gets £32.40. And of course I could check that the others add up to make the whole thing add up to 54. So I should get that Tarish gets £16.20 and Ben gets just Peter just gets the X amount, which is £5.40. So they should all add up to £54 in the end. 32.40, 16.20 and £5.40. 8, 9, 10, 5, 11, 12, 13, 14. That's 54. So that works. Question 3. On the grid, draw the graph of x plus y equals 4 for values of x from -2 to 5. What I could do here is a table of values. I don't necessarily need to do this because you might already know what the graph of x plus y equals 4 looks like. It's a graph that has a gradient of -1 and passes through these coordinates here and here. If you weren't sure of that though, you could do, well, if x is -2, then y must be 6 in order for them to add together to make 4. When x is 0, y equals 4. When x is 2, y equals 2. 4, 0. And just make sure that you go from the starting point, -2, 6, all the way to the point where x equals 5. So that's what the line should look like there. Question 4. PQRS is a square. All measurements are in centimetres, and here's the square labelled 3x minus 2 on one side and x plus 1 on the other side. Show that the perimeter of the square is 10 centimetres. For this I'm going to have to solve what x is, and I know from this, because the two sides of the square are equal, because it's a square, I can set the one side equal to the other side, and then I subtract x from both sides. Gives me 2x minus 2 equals 1, and 2 to both sides, 2x equals 3. Divide both sides by 2, that gives me x equals 1.5. Perimeter, so for that I need to show both sides, so 3x minus 2 equals 3 times 1.5 minus 2, which is 4.5, minus 2, which is 2.5. And this side is x plus 1, which also equals 1.5 plus 1, which is 2.5. So, as it's a show that question, I'm just going to state both sides equal 2.5 centimeters. Perimeter equals 4 times 2.5 centimeters, which equals 10 centimeters. Question 5. The diagram shows the plan of a floor. The area of the floor is 138 meters squared. Work out the value of x. Well, I'm going to need to divide this into sections. I can work out this area here. That's 15 times 8, which is 40 plus 8, 120. So this area here is 120 meters squared. To do the next bit, I need to work out the area of this section here, and this length here I can only get in terms of x. If this is x here, then this length here is 15 minus x. This won't be the only way to do this question, but if that length is 15 minus x, and I take away the 120 meters squared from the overall area, 138 total minus 120 equals 18 meters squared. And I know that the area of this section here equals that area, so that's 3 times by 15 minus x equals 18. Divide both sides by 3. (15 minus x equals 6). Therefore, x equals 9. 15 minus 9 equals 6. And again, you would want to check that that works. We've got, if I break it down the other way, that would give me a section of 9 by 8. And another section of 6 by 11, which would be, so 8 9's 72 plus 66, that's 8, 6 and 7 makes 138. So that does work. It's added up to the correct thing. And by looking at the areas in two different ways, I've checked in such a way that I can be sure that my answer is now correct. It works for both different ways. There are 40 litres of water in a barrel. Quick sketch. The water flows out of the barrel at a rate of 125 millilitres per second. 1 litre equals 1,000 millilitres. Work out the time it takes for the barrel to empty completely. So we've got 40 litres, 125 millilitres per second. If I multiply that by 2 gets me to 250, times by 2 again gets me to 500, times by 2 again gets me to 1 litre, 1,000 millilitres. If I do that per second, then it's per 2 seconds, times by 2 is per 4 seconds, and 1 litre per 8 seconds. And I've got 40 of these litres, so 40 times by 8, 4 8s are 32, so that's 320 seconds. And we'll see what unit it asks for. It just in seconds, so I don't have to do any minute conversions there, just 320 seconds in total. 2/5 plus a quarter. In order for me to be able to add the fractions, they have to have the same denominator, so I choose the lowest common multiple of 5 and 4, which is 20. So times that one top and bottom by 4, that's 8/20. Second fraction times top and bottom by 5, and that is 5/20, so overall that is 13/20. 20ths, and I can't simplify that, so that is my answer. 3 1/8 times by 2/5. I'm going to turn them both into, well, this one into an improper fraction. 3/8 are 24, plus the one is 25/8 times by 2/5. I can do that calculation, but I could also cancel these because they can both be divided by 5, leaving me with 5 and 1, and these can both be divided by 2, leaving me with 4 and 1. So that's 5 times 1, 5 over 4 times 1, 4, which is 1 1/4. Giving your answer as a fraction in its simplest form is 1 1/4. Just to check this, if I hadn't simplified earlier on, I would have just multiplied the numerators and got 50 over 5/8 of 40, which cancels to 5 over 4 anyway. So whichever method you're happier with. Lillian, Max and Nadia share a sum of money in the ratio 2 to 3 to 5. What fraction of the money does Max receive? So overall there are 5 plus 3 plus 2 equals 10 shares. Max receives 3 out of every 10. So the fraction of money is 3/10. Nazia receives £60. Work out how much money Lillian receives. Well, Nazia gets 5 out of 10, which is a half. So Nazia gets half the money. Nazia gets half the money, so total is £60. No, total is £120. Half the money is £60, total is £120. And Lillian gets 2/10 of the money, 1/5 of the money. So 120 over 5, or 5 into 120, goes 14 times. So 1/5 of £120 is £14, and that's what Lillian receives. In this one, I need to get all of the y's on the same side to begin with, so I'm going to add 4y to both sides, leaving me with 11 plus equals 10y minus 3. Add 3 to both sides. 14 equals 10y. Divide by 10. And that gives me y equals 1.4. Solving this quadratic, it has to be equal to 0 in order to solve the quadratic, and this one already is equal to 0. So I can try this by factorizing it. It's a quadratic because it's got an x squared, and an x term, and a number term. It's minus 40, which means that I've got a plus and a minus number in here. And possible factors are things that multiply to 40, 4 and 10, 1 and 40 obviously, 2 and 20, and 5 and 8. And I'm always looking for numbers that are 3 apart. So none of these work, but 5 and 8 do work, and then I've got to make sure that I've got minus 3 as an outcome, so that's minus 8 and plus 5, more negative than positive, to end up with minus 3x there. Having got that far, either x plus 5 equals 0, in which case x equals minus 5, or x minus 8 equals 0, in which case x equals 8. There are 11 pens in a box. 6 of the pens are black, 3 of the pens are red, 2 of the pens are green. Henry takes at random 2 pens from the box. Work out the probability that he takes 1 black pen and 1 green pen. Well, I'm going to do a abbreviated tree diagram for this one. I'm going to just call this pick 1 and this pick 2. And we're interested in him taking 1 black pen and 1 green pen. So I'm going to call this black followed by green, and then this one is green followed by black. Probability that he takes a black pen first of all, 6 out of the 11, and green is 2 out of the 11. If he's taken a black one already, then there are still 2 green ones, but there are only 10 pens remaining. If he's taken a green one already, then there are 6 black ones, but only out of 10 again. So probability of black then green is 6/11 times by 2/10, which is 12 over 110. And the probability of green then black is 2/11 times by 6/10, which is also 12 over 110. So either way we go, remembering always to multiply along the branches, either way there's a probability of 12 over 110. But of course either way is possible, and therefore in order to know the probability of exactly one black pen and one green pen, I need to add together these 2 possible ways. So that is 12 plus 12 over 110, which is 24 over 110, which is the same as 12 over 55, dividing top and bottom by 2. You don't need to simplify for the final mark on probability questions, but there's no reason why not to. Generally, fraction answers are better given in their simplest form, so that's a good mathematical answer to simplify that there. Question 11. This is a difficult one to visualize. The size of the obtuse angle in an isosceles triangle is x degrees. Write an expression in terms of x for the size in degrees of one of the other 2 angles. Now, if we're thinking isosceles triangle, you might think like that, where these are equal, and it could also be like that, again where these are equal. Now in this case, the size of the obtuse angle, that is an angle between 90 and 180 degrees. And if you think about it, there can only be one of those in a triangle, ever. Because the other 2 triangles have to add to, well, the other 2 angles have to add to what's left out of 180. So all 3 angles have to add to 180. If one of them is more than half of that, then the other 2 cannot be more than half of that. So rather than this one, where this is not an obtuse angle, in this case that could be an obtuse angle of x. These 2 angles would therefore be add together to be 180 minus x, the remaining 2 angles. But we then need to divide that angle by 2, so the final answer would be 180 minus x all over 2, or you might want to write that as 90 minus x over 2 degrees. Question 12. Write down the value of 9 to the power and a half. 9 to the power of a half is the same as square root of 9, which is 3. Write down the value of 8 to the power of minus a third. Well, that first of all deal with the minus sign. That is 1 over 8 to the power of a third. That's what the minus sign does. It makes it a reciprocal. 8 to the power of a third is 1 over the cube root of 8, which is 2. So equals 1 over the cube root of 8, 1 over 2. Part C, 2 to the power of k equals 16. Write down the value of k. So 2 times 2 equals 4, that's 2 squared. 2 times 2 times 2 equals 8, that's 2 cubed. 2 times 2 times 2 times 2 equals 16, and that's 2 to the power of 4. So we've got 16, k must equal 4. Solve 8 to the power of 5 equals 2 to the power of m plus 3. This is difficult because we need to arrange this side so that it's a power of 2. I know that 8 is a power of 2, so I'm going to call this 8 is actually 2 cubed. So I'm going to call that 2 cubed to the power of 5 is the same as 2 to the power of 2m plus 3. Expanding that 2 cubed, we use the power law there, so 2 to the power of 3 all to the power of 5 is the same as 2 to the power of 3 times 5, 15, equals 2 to the power of 2m plus 3, which must mean, if you look at that with the 2's as your base numbers there, 15 must equal 2m plus 3, and now I've got a linear equation to solve, so minus 3 from both sides, 12 equals 2m, divide both sides by 2, 6 equals m. Question 13, box plot. Tom recorded the times in seconds some boys took to complete an obstacle course. He drew this box plot for his results. So the time there, we can see a median a time of 115 seconds, and the range there going from 95 up to 136 seconds. Tom also recorded the times some girls took to complete the obstacle course. Here are the times in seconds for the girls, so he's written out the times in seconds, and they are already in ascending order, so we don't have to change the order. We can see that they're in ascending order already. Compare the distribution of times for the boys with the distribution of times for the girls. So as a general principle, when we see compare distributions, that means compare an average and compare a range. So if we put some facts, it'll also need, because it's a compare question, it'll also need some written description. But let's do some calculation first of all. So we can't work out a mean or a median from the boys' results, because it's, a mean or a mode from the boys' results, because they're given as a box plot, but we can work out the median. So the median for the boys is 115. And for the girls, it's the middle number. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 values. The middle value is going to be the n plus 1 over 2th value. So that's the 10th value. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And quite obviously actually the 1 on its own at the end of that line. So girls' median is 112. Range for boys, we've got 136 minus 95. So that is 13 minus 9 is 4, 41. And for the girls, we've got 132 minus 99, so that's 33. And that gives me enough to compare these two, but also I should be able to calculate the interquartile range. So interquartile range for the boys is going to be 120 minus 101 to 103. So that is 17. And for the girls, the quartiles are, well, they're at 19 plus 1 over 4, which is the 5th value. 1, 2, 3, 4, 5. So 108 is the lower quartile. And the upper quartile is 5 from the other end. 1, 2, 3, 4, 5. 117 minus 108, which is 11. Is it? No, it's 9. So in comparing these, I should put some context as well. So in the question it says that they're running an obstacle course, racing an obstacle course. So I can say that the girls' median times is faster than the boys. And I'm going to put in the values as well. Girls' median time, 112, is faster than the boys, 115. there is a greater range of times for the boys than the girls. And I'm again putting the values into that sentence. And also mention interquartile range. For boys than girls. As a general conclusion to that, then, the boys seem to be slower and less consistent. So slower is a reaction to the median time, and less consistent is a reaction to the range of times. The boys have a bigger range of times. It's for 4 marks. I've done a lot of calculation and a lot of writing. Within that, though, I hope to have covered all the possible areas where it might be required to get a mark, because I've communicated my answer and I've also shown the calculations of the various ways of measuring the spread using range or interquartile range, as well as comparing an average. So I think I've got it all covered there. Question 14. Write 8.2 times 10 to the power of 5 as an ordinary number. Well, 8.2 times 10 would be 82, times 10 squared, times 10 cubed, times 10 to the power of 4, times 10 to the power of 5. It's 820,000. Make sure that's a comma, not a decimal point, just in case. There's actually no need for a comma there. If it's got the right number of zeros, that's fine. Write 0.000376 in standard form. Well, if I was moving it there, that would be times 10 to the power of minus 1, 10 to the power of minus 2, 10 to the power of minus 3, 10 to the power of minus 4, and that's where I want it, with a number between 1 and 10 at the start, so 3.76 times 10 to the power of minus 4. This value here, work out the value of 2.3 times 10 to the power of 12 divided by 4.6 times 10 to the power of 3. Well, I can do the number bit separately to the powers of 10 bit, so that's 2.3 over 4.6 times by 10 to the power of 12 over 10 to the power of 3. So 2.3 over 4.6 is the same as 0.5, that's a half. If I look at that as a fraction, that's 1 over 2, times by 10 to the power of 12 divided by 10 to the power of 3. 12 minus 3 is 9, so that's what that looks like. But this isn't yet in standard form, because this number is not between 1 and 10. So I'm going to times this number by 10, which means that as a result I should make this number 10 times smaller. 5 times 10 to the 8. Question 15, vectors question. In the diagram, OB equals B, OC, short distance there, equals C. OC equals 1/3 of OA, so I'm going to already just mark that. That's 1/3 of the whole distance OA, so that's 1 to 2 there. BD equals 1/4 BA. So BD equals 1/4 BA, that means 3 to 1 distance there. Find CD in terms of B and C. So CD a route I could do to get to CD would be to go CO plus O to B plus BD. CO I can replace with the vector C, minus C, it's going in the other direction. OC is C, so CO is minus C. OB is B in the same direction, and BD is a bit more complicated. So BD is 1/4 of BA. So I'm going to replace that that BD with 1/4 of BA. and keep on working on this. BA is the same as B to O plus O to A. So that is a quarter of, well, BO is minus B, and OA is 3 lots of C, 3 lots of OC, which is 3C. So putting that all together, CD equals minus C plus B plus a quarter of minus B plus a quarter of 3C. So expanding that bracket, I've got minus C plus B minus 1/4 B plus 3/4 of C. So collecting like terms, or like vectors, B minus 1/4 B is 3/4 of B, and minus C plus 3/4 of C is minus 1/4 of C. And that's my answer for CD in terms of B and C. It asks for the simplest form. I suppose I could put that as 1/4 of 3B minus C. That looks a bit simpler there. So that's my final answer. There may well be other ways to do that that might be simpler, but that seemed to be the first, well, it was just the first thing that came to my mind. Question 16, a probability question. Two events A and B are mutually exclusive. Probability of A 0.3 and probability of B is 0.5. Work out the probability of A dash, which means probability of not A happening. And that's just 1 minus the probability of A happening, so that is 0.7. Work out the probability of A union B, that's A happening or B happening or both. If I think about the Venn diagram of this, they're mutually exclusive, so A and B cannot happen at the same time. Which means that the probability of either one happening or both happening, well, there is no both happening, so either one happening is 0.3 plus 0.5. So that's 0.8. Probability of C is 0.4, probability of D is 0.2, and the probability of their intersection is 0.06. Are they independent events? Well, if events are independent, then the probability of each of them happening has to be multiplied together to achieve the intersection of C and D. So for this, I would have to show that if the events were independent, probability of C times by the probability of D would equal probability of C intersection D. But 0.4 times by 0.2 equals 0.08, which is not equal to 0.06. So the events are not independent. Difficult 2 marks, that one. Question 17, simplify fully 2x squared plus 9x minus 5 over 6x squared minus 5x plus 1. So, as always with algebraic fractions, factorize first. In this case, there's nothing else you can do, but always factorize first with algebraic fractions and simplify as much as possible. So in this, the numerator, I've got two numbers that multiply to 5 at the end, and an x squared and a 2x, well, an x and a 2x at the beginning of the brackets. I would generally just do this by shuffling around. 2x times 5 is 10x, and if you minus the x from that, you get the 9x that you're left in the middle with, and that's plus 5 times minus 1 is minus 5. And now when I've done that, I would expect the denominator to have at least one of these in. Well, it's only one of these factors in. Because it ends up with a +1, and there's a minus sign in the middle, that tells me that both of these are -1. -1 times -1 is +1. Because I'm expecting one of these to be down here, the only one that's now going to fit is 2x minus 1, which would mean that the other one must be 3x. 3 times 2 making the 6. And let's just check that. 3x times 2x is 6x squared. Minus 2x minus 3x is minus 5x altogether. -1 times -1 is +1. So that does work. It factorizes correctly, which means I can now cancel those two sections, and that's just x plus 5 over 3x minus 1. And that's as simple as it'll get. There's no common factor of the numerator and denominator at that point. So that's the final answer for that. X plus 5 over 3x minus 1. Question 18. AB is a diameter of a circle. So that's a diameter, which means it must go through the center of the circle. C is a point on the circle. D is a point inside the circle such that BD equals BC, and BD is parallel to CA. Find the size of angle CDB. So mark that in as the first thing you do. That's what we're looking for. You must give reasons for your answer. Well, the first thing I'm thinking is that angle ACB is 90 degrees, because angles in a semicircle, or the angle in a semicircle, is 90 degrees. And I know it's a semicircle because I'm told that AB is a diameter. So that tells me that that is 90 degrees. I also know that those two angles are the same because it's isosceles here, but I'm not sure if that's going to help me in this case. Thinking about angles on parallel lines though, that angle must be equal to that angle because of alternate angles on parallel lines being equal. So, given that ACB is 90 degrees, if those two are equal, and those two are equal, these two must be equal, which means that they're each 45 degrees. So I now need to put that into words. My answer is 45 degrees, but I will explain that as angle BCD equals angle BDC, because base angles in an isosceles triangle are equal. And then angle ACD equals angle BDC. Because alternate angles on parallel lines are equal. So that tells me that ACD plus DCB let's check I've got the right things there. DCB, ACD equals 90 degrees, and ACD equals angle DCB. Therefore, angle ACD equals 45 degrees, 90 degrees divided by 2. And so, angle CDB, the one I'm looking for, equals angle ACD as above. Therefore, angle CDB equals 45 degrees. I'm fairly sure that the mark scheme doesn't necessarily involve all of that writing, but it will include all of those points. We need to mention the isosceles triangle, the alternate angles on parallel lines, the fact that that's 90 degrees in here, and that these two must equal each other for what I've mentioned already. So it needs that whole process of logic to justify calling that 45 degrees CDB. Question 19. Series of graphs. Each equation in the table represents one of the graphs A to F. Write the letter of each graph in the correct place in the table. So y equals 4 sine x. That means like a sine graph, which is the simplest one, starting at 0, 0 for sine, and doing a wave like that, apart from it's 4 times bigger. But it still has to go through 0, 0, because 4 times 0 is still 0. So 4 times a steep looks like that one, and it goes through 0, 0, so I'm going to call that E. Y equals 4 cos x is this other repeating graph. Has to be, because it's a cosine, well, it's a wave, so it's a cosine or a sine. And this one also, at 90 degrees, is still 0. So this is 4 times the normal cosine graph, so that is B. Y equals x squared minus 4x plus 5. That's a quadratic. The only one that's got a quadratic shape here is graph F, which has got the parabola, or the bottom end of a parabola there. It should also have no solutions because it doesn't cross, so I can check whether b squared minus 4ac is greater than or equal to 0. B squared is minus 4 squared, that's 16, minus 4 times 1 times 5. So minus 20 is minus 4, and I can't square root minus 4 because this has no solution. So that works, and that's correct. Y equals 4 to the power of 2x. That is a exponential graph, which is one that starts like this and goes up very steeply. So that's C. Y equals x cubed plus 4 is this one that goes, any graph that looks like it's got 2 turning points, even if they're shallow, or even if it's a point of inflection, is a cubic, so that's D. And then y equals 4 over x is a reciprocal graph, which is this one. Some multiple of 1 over x, and they all look like that. So that's graph A for that one there. Only 3 marks for that, presumably because once you've got 1 correct or 2 correct, the rest fall into place. Question 20, expand this surds in double brackets. So, as usual, firsts, outsides, insides, lasts. So firsts is 3. Outsides is minus 1 root 2, so that's just minus root 2. Insides is plus 3 root 2. And last is root 2 times by minus root 2, which is minus 2. Collecting together the surd parts and the whole number parts, I've got 3 minus 2, which is 1. And 3 root 2 minus root 2, which is 2 root 2. And that's my answer, 1 plus 2 root 2. So question 21. Umar thinks that a plus 1 squared equals a squared plus 1 for all values of a. Show that Umar is wrong. Well, I can just prove this by counterexample, or disprove it by counterexample. So I'm going to say when a equals 1, a plus 1 squared equals 2 squared equals 4. A squared plus 1 equals 1 plus 1 equals 2. 2 does not equal 4. Therefore, Umar is wrong. Here are 2 right-angled triangles. All the measurements are in centimeters. So we've got ABC, a plus 1, b plus 1, c plus 1. Show that 2a plus 2b plus 1 equals 2c. I'm not entirely sure how that's going to work at the moment, but I expect it's to do with Pythagoras' theorem because we've got two right-angled triangles. So on this triangle I've got a squared plus b squared equals c squared, and on this triangle I've got a plus 1 squared plus b plus 1 squared equals c plus 1 squared. If I expand each of these brackets, that's a plus 1 plus b plus 1 equals c plus 1 c plus 1. And this I don't know whether this is going to lead to the right thing here. I'm just assuming that it will get me somewhere that I can see. I'm not sure where it's going so far. I'm just doing what I can. So a squared plus 1a plus 1a, so that's a squared plus 2a plus 1, plus b squared plus 2b plus 1 equals c squared plus 2c plus 1. If I collect those things together, I've got a squared plus b squared plus 2a plus 2b plus 2 equals c squared plus 2c plus 1. And I know that a squared plus b squared equals c squared, so I can subtract that from both sides. I'm just going to write that here. Subtract. A squared minus a squared is 0, b squared minus b squared is 0, and the rest is left over, plus 2. C squared minus c squared equals 0, plus 2c plus 1. So this is sort of like the simultaneous equations method. As long as the two things equal each other on both sides, I can subtract one from the other. I need to show that 2a plus 2b plus 1 equals 2c, so I'm very nearly there now. 2a plus 2b plus 2 equals 2c plus 1, minus 1 from both sides, and that gives me 2a plus 2b plus 1 equals 2c, which is what I had to show. A, b, and c cannot all be integers. Explain why. C cannot all be integers. Explain why. If I just look at the solution that I've got to here, 2a plus 2b plus 1 equals 2c. I could factorize that. That's 2a plus b plus 1 equals 2c. And effectively what it needs to be said here is that if that's an even number, then the whole of the left-hand side is odd, and therefore c must, well, if you divide an odd number by 2, you get a 0.5, a decimal. So let's say if a and b are integers, are integers, 2a plus b plus 1 will be an odd number, therefore 2c would be an odd number, and c cannot be an integer. So impossible for all three to be integers. Or for a, b, and c to all be integers. Difficult one to explain that at the end. I don't think it probably doesn't need that full explanation. It just needs to have an acknowledgement of the fact that there's an odd number on one side and an even number on the other side, and so that can only work. Well, it can never work. That this equation can only work if one of these, at least one of these, is not an integer. That's what it's aiming at there. And that's the end of that paper.